I assume your studies would show something similar, Greg?
Yes, they would. As an extension specialist, I get asked to speak about nitrogen stabilizers. Actually, I've been to Iowa this year, Indiana, Pennsylvania, Maryland, quite often asked to speak about nitrogen stabilizers. And I find that when I talk to people that there's actually a lot of confusion out there in terms of what is meant by a nitrogen stabilizer, because there's different types of nitrogen stabilizers. We've got nitrogen stabilizers that are urease inhibitors. We have nitrogen stabilizers that are nitrification inhibitors. And then we've also have products that are slow release products that are classified as nitrogen stabilizers. And ultimately, what we're trying to do is increase the efficiency of nitrogen, trying to get more nitrogen into that plant. And one of the things I always promote to farmers, whoever I'm talking to, is that when you're looking at any type of nitrogen stabilizer, ask the question or ask for data to show that that nitrogen stabilizer in fact does what it says it's going to do. And so one of the slides I most often start with when I talk about AGROTAIN is the first slide here. That's actually this is data that was collected by a colleague of mine, Dr. Rick Norman. Rick is at the University of Arkansas and does a lot of work in rice where they have a lot of volatilization potential. And he also has a laboratory set up where he can do some volatilization type work. And this is what we're actually looking at in this graph. This is a laboratory study. This is not field data. But the thing to keep in mind about these, you see a significant amount of volatilization. What this graph is actually showing is nitrogen volatilized as a percentage of the amount that was applied on that y-axis. So you can see if you look at the urea curve, almost 60%, over half the nitrogen was lost as volatilization. You have to keep in mind that that is in a laboratory situation. But that is a very valid method to actually compare different products and see if they do what they say they're going to do. And one of the things that you'll always see when you look at AGROTAIN is you'll see a depression in volatilization. And so if you look at that middle line where it says urea plus AGROTAIN, you can see at 0 and 3 days there's no volatilization that has yet occurred with the AGROTAIN. And typically it's put on at a rate that you expect, the number of days that you expect to need that protection. And then eventually that material will break down and you'll start to see volatilization. As a control, Rick used ammonium sulfate in this study, and that's what the AMS is down at the bottom. He put ammonium sulfate on at the same rate of nitrogen, and you see you didn't get any volatilization, which ammonium sulfate is a product that will not volatilize unless you're on a very high pH soil. And this was a pH in the low 6s. So again, my point with this information is just to show that the product does in fact inhibit volatilization. If we go to the next slide then, this is actually some published data. This is not my data again. This is data that was published in the Agronomy Journal, which is one of the key scientific journals that we use in agronomy sciences. And so this has been a peer-reviewed publication. But what this shows on the y-axis is your percent of recovered fertilizer nitrogen as ammonium nitrogen. Whenever we talk about a nitrification inhibitor is designed to keep the nitrogen in the ammonium form. It's NH4 with a plus charge. We keep it in that plus charge so it's held on the cation exchange sites. So that's all a nitrification inhibitor is doing, is keeping that nitrogen in the ammonium form. If you look at this graph, they're comparing Super U with urea, and Super U is a product that has AGROTAIN, but it also has DCD, the component that gives the nitrification inhibition. And if you look at on the x-axis is basically heat units or time, and as it gets warm, you expect that ammonium to nitrify over to nitrate. And so a urea graph is showing that you are, as you get out there to 300 heat units, you've only got about 20% of your ammonium left. Whereas if you use Super U, you can see there's a significant more of that material still in the ammonium form, which shows you that it is in fact slowing down nitrification, which is what the goal is. So I always point out that these products should be shown to do that. If we go on to the next slide, this is actually a data set published by Dr. Dick Fox, who's now retired, but he worked in nitrogen fertility at Penn State University for many years, and this is published in the Agronomy Journal. This is actually a 3-year study in no-till corn where he was basically just looking at urea with and without AGROTAIN, and then he also, as Greg pointed out, ammonium nitrate is a product that will not volatilize on you, and so that's kind of your control and your check. And you can see with the ammonium nitrate and the urea with AGROTAIN, they yielded basically the same. There was no significant difference, but urea without AGROTAIN was yielded 20 bushels less. And so again, this is a 3-year study, just data showing that it works. And now if we go on to the next slide, this is actually some of the work that I've been doing. I've been evaluating different products for the last 4 or 5 years at the University of Delaware. And what this is actually showing, what we did in this study, we had 4 different rates of nitrogen, actually 5 if you include the control. 50, 100, 150, and 200 pounds of nitrogen along the y-axis, or along the x-axis, I'm sorry. And then along the y-axis, what you're looking at is leaf chlorophyll using a SPAD meter, which basically measures the relative greenness of the plant and tells you, it gives you a relative reading of the nitrogen status. So if you look, let's just go out and pick one rate in this figure. If we go to the 150 pound rate, the gray bar is the chlorophyll meter reading with just urea. The green bar is urea with AGROTAIN, and the blue bar is Super U. And so you can see that we clearly had a volatilization issue here, and also getting some protection from the DCD that's in Super U. And in this situation, I put the data on here where this was applied on June 1. This was side dress corn coming in and putting on urea on the soil surface. In that type of situation, you have a very high potential for loss because you've got warm conditions. And you can, I have the temperatures over the first 4 days, and then rainfall that occurred on that day 5. So you can see we got a significant response. Or actually, this is not showing yield. I take that back. This is showing the nitrogen content of the plant, if you will. Go to the next slide, and it actually looks basically the same. This is the yield data. And you can see we had about a 30 bushel response to using either urea, or actually I think with the Super U it ended up being close to a 30 bushel response. But so we had an impact of both of these products. So that's basically what I wanted to present, Kyle.
Well, that's some great background. It gives everybody an idea of what the products can do.